Hello friends, welcome back. In the previous video, we have discussed about how to perform the insertion operation in case of a single linked list. That is, we have discussed about both the function that can be used to insert a new node at the beginning of the list, as well as the function to insert a new node at the end of the list. In today's video, we'll be discussing about how to perform the deletion operation. That is, how to perform the deletion operation from the beginning of the list as well as from the end of the list. So first we'll be taking up to delete a node. At the beginning of the list. Let me have the function name as delete begin. After deleting a node from the list, let the node return the address of the first node. So the return type of the function as capital node. Argument to the function is the reference of my node, reference of my single linked list which was stored in the variable start. That was start was holding the address of the first node. Now, as we know that if list is empty, it is not at all possible to perform a deletion operation. How to check whether a single linked list is empty or not? Just check if start is having none, list is empty. If start is equal to none, printf list is empty. Return. If you see, this delete function have to return an address. So return, if you write start also there is no problem. Even if you write return null also there is no problem. So if list is empty, then you can't perform a deletion operation. Assume that list is not empty. There are some nodes in the linked list. I will assume that there are 4 nodes in the linked list. So this was my start. This was my 10, 20, 30 and 40. Now what is my objective? My objective is to delete the first node. Now my objective is to delete the first node. Let me take a variable by name temp. Now make temp to hold the address of the first node as similar to that of start. Now what I have done? I have made temp to hold the address of the first node. Now make sure that start after deletion, after deleting 10, now start should contain the address of the second node. Now change start to the second node. You have to change this start, instead of holding the address of the first node, to the second node. Second node address is there in start of address itself. That is, make start is equal to start of address. Done. Okay, now delete temp. Now delete temp. So we'll just have a printf statement. Printf node deleted is %d. Okay, node means I'll just print this information which I am deleting. So that is there in my temp of data. Now, in case of dynamic memory allocation, deletion is nothing but you have to deallocate the memory. How to deallocate the memory? To deallocate memory, you are supposed to call a function by name free of temp. What happens? Okay, the memory will be deallocated. Now return the address of the node which is holding. Now return the address of the node which is holding the address of 20. So which it is there in start. Return start. It's quite simple one. What you do? Initially you are making temp to hold the address of the first node. I think that statement was missing here. Make temp to hold the address of the first node and then change the start to hold the address of the second node. Start is equal to start of address. Now delete temp, you are deallocating the memory and then you are returning the address of the second node. Second node is nothing but my node wherein information 20 is there. So this is about how to delete a node at the beginning of the list. Now moving on quickly, we'll see how to delete a node at the end of the list. Function name delete end. The argument is the reference of my list node start. Now I'll check. First thing, okay, if list is empty, I can't perform the deletion operation. That's the first thing that I'm going to check. If start is equal to null printf list is empty, return null. If list is not empty, then I have to think how to perform the deletion operation. Now assume that this was my linked list with 4 nodes. Now my objective is to delete the last node. If I know the address of the last node, I can delete. But unluckily, I don't know the address of the last node. Only thing that I know is the address of the first node. Anyway, from first node, I can traverse till last node. That is possible. But while traversing, I should also get the reference of the last but one node. Why? Because once I delete last but one node becomes the last node. And in case of a single linked list, I should hold the address of the last node as null. So I should have 2 references. So in the variable declaration, I will declare 2 variables, one variable by name current and one more variable by name previous. Now what I will do, initially I will make previous pointing to null. It is not pointing to anywhere, and then current pointing to start. So this is my current. And what is my previous? Assume that okay, previous is null. I'll assume that my previous is somewhere pointing here. It is not pointing to any of the node. Now what I need to do, I need to traverse both current as well as previous such that current is pointing to last node and previous pointing to last but one node. Let's see how to do. Same thing, take a while loop. While current of address not equal to null. First thing is make previous as current and then change your current to next node. Current is equal to current of address. Close your while loop. Let's see what happens. While current of address is second node there, yes. Now make your previous as a current. Your previous is pointing to, is nowhere pointing. Now make it to point to current. So this becomes your previous. And what happens to current? Current is equal to current of address. Current will be pointing to the next node. I am in a while loop. While current of address is third node. It is there. So make your current as previous. Your previous will be changed as well as your current will be changed to the next node. Next, current of address is fourth node there. Yes, previous is equal to current. This becomes your previous. And then your current shifts to the last node. Now while loop. While current of address not equal to null. Current of address is null. So this part will not be executed. Now if you see, I have got the address of last node as well as the last but one node. Now I have to delete this current. I very well know that. So before deleting, make previous of address as null. So now previous of address is pointing to current. Now make previous of address is equal to null. previous of address which was pointing to current, now I will make it as null. Now I know that which is the node to be deleted. Node to be deleted is current. Printf node deleted is %d, which is nothing but current of data. It is not just deleting, you have to deallocate the memory free of current. If I call free of current, the memory will be deallocated. Now return the address. Your delete function should return the address of the first node. Where is the first node? First node address is there in start. I have not changed anything there. So return start. Hope this is clear. This is about how to perform a deletion operation at the end of the list. We'll even discuss, okay, how to perform the display operation. Coming to display operation, let me have function name as a display. Function name as a display. Return type of the display function as void. Now in case of the insertion and the deletion function, after performing the insertion at the beginning or insertion at the end, or the deletion from the beginning or the deletion at the end, I was returning the address of the first node. Now in case of display, I am not going to alter the number of nodes in the linked list, so I am having the return type of the function as a void. Argument to the function is the reference of your list, that is node start. Same old things. If start is null, list is empty. I can't display anything. If start is equal to null, printf list is empty. If start is there, then list is there. Printf list content are. Now what I am supposed to do, let me take a scenario wherein there is a single linked list with some 4 nodes. Last node link is null. 2, 4, 6, 8 is the information. This is my start. So this is my reference of, this is the list that is given to me, and I am supposed to perform the display operation. I need to display 2, 4, 6, 8. So take a variable by name temp, make temp to hold the address of first node. Temp is equal to start. Now temp is pointing here. Now what you need to do, just print temp of info. Just keep printing temp of info. Printf %d, a tab space, print temp of data. Keep printing the temp of data and change the link of temp from the current node to the next node. Temp is equal to temp of address until where I should shift the temp until it becomes null. So put these 2 statements in a while loop. While temp not equal to null. Note that I am not using temp of address not equal to null. If I use the temp of address, last node will be skipped. So now check what happens. Temp is equal to start, temp is equal to start, temp not equal to null. Temp is holding the address of a node. Print temp of data, 2 gets printed. Temp is equal to temp of address. Now this becomes my temp. Now temp is holding some address. Yes, this condition is true. Print temp of data, 2 gets printed, 4 gets printed. Change the reference of temp to the next node. Next, temp is holding a node address. Yes. Print temp of data, 6 gets printed. Change the reference of temp. Now temp not equal to null. See this properly. Temp not equal to null is fine. If you would have written temp of address not equal to null, in this case the temp of address is null. So what would have happened? I would have not printed 8. Now as I am using temp not equal to null, temp is holding the address of a node. Yes, it is true. Print temp of data, 8 gets printed, and next temp is equal to temp of address. What is there in temp of address? It is null. Now this is my temp. This is my temp. Now temp becomes null. It will come of the while statement. So close your else and close your function. Hope this is fine. This is about how to perform a display operation in case of a single linked list. Thank you.